So g'day, how you going? And I'm at Tai Tam Moon, that's how you say it, reservoir. And as you can see, the reservoir is actually in the background. It's actually quite a nice day, and you can see the large mountain peaks, and the dam is a little bit empty. So on this side we have the major dam itself, and if you look on this side, there's a lot of colluvium, which has just come pretty much from the formation that you can see over there. That seems like to be the Eutaxitic tuff, so it's just tuff that's been squashed, and a lot of this you can actually still see the fine vesicles that you can see in the tuff, and a lot of it has banded pyroclastic flows. And on this side it might look like what you think is a geological formation with the sedimentary strata, but this is really just the erosion level of the actual lake. At different times you've got different periods where the water is lapping at the sides, and that's just causing the differential weathering. So you've got this side, and if you walk over to the other side, which is the inlet, so today's actually quite a lot of people, so I keep on having to stop and start these videos because a lot of them are just talking crap and they're very noisy. Now, it's up to them. But anyway, so we get on. So we're on the other side of the actual dam, and what we see here is the actual tuff, so the Eutaxitic tuff probably. I don't see any conglomerate. So this is a sedimentary rock pretty much. It can be an igneous rock, depends how it is actually formed. Different ways this stuff is formed. Usually pyroclastic flows where the rock comes down from the actual volcano, slides down in like a landslide, and it forms large formations, or could actually be suspended in the air and actually come down to so it's been spit out by the actual volcano. So you've got the volcano, it spits it out, and then it comes down, lands in another place. But all this is pretty much site derived, and over that way, over the peak, we have the granites. So that would have been the main magma body in which the actual volcano would have come out, spit out, and the tuff is actually quite close. So I've never seen any contact between the two, but maybe there will be like a side of a caldera somewhere. But the tuff is usually angular in its actual formation, so it actually is not like the onion exfoliation of the actual granite, because they have larger crystals. This is very fine crystals to vitric, so it's like a glass in a lot of the actual structure, so there is no crystal formation. So it actually breaks like glass. Like when you smash glass, the angles are usually 90 degrees in a lot of cases. It does have conchoidal fracture, but so it really has no plane of fracture. So that's why you get a lot of different ways this actually fractures, and a lot of it is at 90 degrees. And on this side, it is quite eroded. So you have a lot of colluvium. So colluvium comes from the sides of the hills, just forms screes on the side. Alluvium would actually be the sedimentary deposits that are taken away via the water column. So you've got alluvium in there, got colluvium on the sides. Anyway, so that's what I've been doing in Hong Kong, just going around seeing people and checking out the actual geology. Quite a nice place, this area. A lot of it is igneous, a lot of granites, a lot of the actual tuff. but there's also sedimentary rock, but that's in another place. I haven't actually seen any of that.